Today, we're going to talk about exceptions. Let's look at the big picture. So exceptions and errors inherit from throwable, and throwable is anything that can be thrown. Errors are JVM level problems. Basically, they're out of your control. You can't really handle them, so we don't even try to catch those. Exceptions, on the other hand, we do try to handle depending on what kind of exception they are. As you can see here, we have runtime exceptions, which are the unchecked exceptions, as well as compile time exceptions, which are the checked exceptions. Now let's look at checked versus runtime exceptions. So checked exceptions, they must be handled or declared. Those are two ways to deal with exceptions, and we'll talk more about that later. They represent conditions that you can recover from, and they're enforced by the compiler. So as you may recall, compile time is basically when we check the code for errors. And if there are any mistakes in the code, then these checked exceptions can be thrown. So here are your checked exceptions, and we have all sorts of exceptions. Notice that many of these have to do with anything involving files or input output. So file not found, input output, or class not found. These are the checked type of exceptions. Next, we have runtime exceptions, and these are the unchecked exceptions. And these do not need to be declared. These are the ones you try to prevent. And these represent errors in our code, like syntax errors, for example, or bugs. And here, unchecked exceptions, like you have a divide function in your math util class, and you're trying to divide by 0, and it gives you an arithmetic exception. Or you're iterating through a list and you give it an index which is outside of the index of your list. So let's say your last index is 5 and you give it an index of 6. It's going to give you this null pointer exception because there's nothing at that index pointing to any object in the heap. Okay. So those are just some examples. You can read through the rest of these. All right, let's start by looking at runtime exceptions. So runtime exceptions are the kinds of exceptions that you prevent. You typically don't try to catch these. You try to prevent these. And here we're defensively coding to do a null check. So if the input is null, we return a message that the input cannot be null, and we just end the program right there. Here, if you're trying to divide by 0, then we have it throw an illegal argument exception. So let's just go ahead and run this. Input cannot be null. Illegal argument exception. Now let's see if we put in something legit. Okay. And it looks like Copilot is kicking in, which is nice. So let's change these. And now our program runs just fine. Okay, let's comment all this out. Move on to checked exceptions. So we'll start with this one. So what this one demonstrates is using declare. So declaring to throw an exception. So we're declaring the exception. So let's go to our throws example here. And as you can see, we're using the throws keyword in the method signature to throw an IO exception, so throw an input output exception, because you're going to take a non-existent file, try to read it, and get an error. So let's go back here, see what happens. Yes, there's an error. We want it to proceed. Yes, there's an IO exception, which is exactly what we expect. We'll comment this out. Move on to the next. So another way you can handle checked exceptions is with a try-catch block. So let's look at this try-catch example. So here we have a try-catch. We're trying to read and close a file, but this file doesn't exist, at least not that I know of. So what will happen? It's going to try to read this file, and then it'll throw an exception when it cannot read this file. So let's just run this and see what happens. Yes, so IO error occurred, and it printed a nice stack trace with this file not found exception. So how do you handle runtime exceptions? You don't. You try to prevent these exceptions, as we see in our examples. You use defensive coding, like here. And unchecked exceptions. You can handle them with a try-catch block, or you can use the declare keyword in the method signature. We also call this as declaring the exception, passing the responsibility up, ducking the exception. You get the gist. So we see examples like this. It tries to read from a file that doesn't exist, and it throws an exception after catching it. Here we declare in the method signature that it's going to throw an exception. Next is try with resources and the finally block. So with checked exceptions, for an example is an IO exception must be handled or declared, and it's compiler enforced. So here's our try. Here's our try block. Try with resources is when it allows a buffered reader to be automatically closed with no resource or memory leaks. So here we have a resource. That's our try with resource. We can take this reader and declare it and instantiate a new buffered reader instance. The catch block, it allows us to catch and handle our exceptions gracefully. And then finally, always executes. The only time your finally block is not going to execute is if you have a system.exit called, or if the JVM crashes. That's pretty much the only reason why finally block will not execute. So here, use try with resources for anything that implements an auto-closable interface. So basically anything that has reader or writer in the class name. Use finally for logic that must always run. Okay. Here, we're going to demonstrate try with resources. So let's go to our try with resources example. So here's our try with resources example. And essentially what we're doing here is we're trying with this resource, which is the reader. So we're taking a reader, instantiating a new instance of buffer reader. This catch allows us to gracefully handle the exception that we will inevitably get when we try to read from a file that doesn't exist. And the finally block executes regardless of what happens, unless the system crashes or you have a system.exit. So let's go ahead and try this. So we'll go back to our run exceptions demo, and we will execute this. So yes, so there's an error reading file. Finally block always executes. Now, since we're talking about try with resources, let's talk a little bit about the finally block. I was planning to talk about this last, but I think we should talk about it here. And this is important because it's kind of like one of those I got you situations. I actually ran into it myself the day before. So all I'm going to do is execute it and read the output because I think the output is going to drive the point home. So we'll save this first as usual. Okay. So we went to the try block. We returned. So in normal circumstances, a return is a full stop. You put it in any method, it will it will halt execution of the method. But not here. It still proceeds to the finally block. And the only way to prevent this from running is to call system.exit or if the JVM crashes. But JVM crashing is not something we can control. Even if we throw an exception in the try block, the finally block will still execute. Even if we return from try block, as we did here, it'll still execute. Why do we have a finally block? It's good for cleaning up resources. It's good for cleaning up resources. Like if you have a database connection, you might want to clean that up, especially since there's a limited number of connections. In this case, we're just demonstrating that finally always runs. All right, here in the try block, I will throw a runtime exception. Do you think the finally block is still going to run? Let's find out. Yes, the finally block still ran and it threw an exception. When to use checked versus runtime exceptions. Use checked exceptions when you can reasonably recover and or when external resources are involved, such as files, databases, network connections. Prevent runtime errors by fixing syntax errors, defensive coding, like we've already demonstrated. If the caller can fix it, checked. If the developer must fix it, runtime. And if that wasn't enough, we can also create our own exceptions. So we can create custom exceptions. So this is an example here. We created a custom exception class called insufficient funds exception, and we're utilizing it here. Well, let's segue to our code, shall we? All right, we're back in our IDE. Here, we're going to demonstrate that we can create our own custom checked exceptions. So let's go to this custom checked exceptions, which is our inefficient funds exception. So all we did here is we extended the exception class. We're calling a constructor, which takes in a message, and it calls the superconstructor to print that message. So this is our custom exception. There's really not much to it. The only reason I have this ID here is because for some reason this IDE mandates that you create an ID when you're creating these custom exceptions. But that's just an aside. Let's get back to our demo. And we've created a bank account class, which will use this bank account and try to overdraft on this account. So let's see, is there anything special in this? Nope, not much special, just a withdrawal method. And as you can see here, where we're using the throws keyword in the method. So we're declaring the exception. We're ducking the exception here. All right, back to the demo class. Okay, let's run this. Okay, input cannot be null. Okay. Oh, we're still running the top one. Yeah, because if you throw an exception, it's going to stop everything else. Okay, let's try this again. Let's do this. Okay, not enough funds. And there you have it, a checked exception. Okay, we have finished talking about exceptions. I hope that you learned something. Please like this video, subscribe, and thank you. Peace.